Hello everyone, how to solve this nice math Olympiad exponential equation problem. So here we have 27 to the power of x equals to minus x, and we solve this problem for the values of x. So here we first solve this problem by method number 1. So in first method, here we need to divide both of the sides by 27 to the power of x. So that we divide both of the sides by 27 to the power of x, and it will be written as 27 to the power of x divided by 27 to the power of x is equals to minus x is divided by 27 to the power of x. So now after that, you see here these two terms are cancelled by each other, so that we get here 1 is equals to, here we move this 27 to the power of x to the upside, so it will be written as minus x into 27 to the power of minus x, because here we apply this nice exponential law. So you know that if we have 1 over a to the power of m, it is equals to a to the power of minus m. Okay, so that now in order to we apply this nice exponential law on this term, so that its exponent will becomes negative. And now after this term, here we need to apply the Lambert W function. So here first we introduce the Lambert W function. So we know that Lambert W function is stated as w of n into e to the power of n is equals to n only. It means that if you have some exponent of e, that is n, so this n is multiplied by here, then the output of this type of function is also equals to n. So this is called the Lambert W function. So now here we use this w function to the above term, so that here first we need to make the exponential term with base e here, so that here you see that this is 27, so we write this 27 as, here we apply the log and anti-log at the same time on 27, so that it will be written as e to the power of log 27. Okay, so now we replace this 27 is equals to e to the power of log 27. So when you replace this term on here, our above term or above equation is written as 1 is equals to minus x into, this is 27, we write it as e to the power of log 27, and its whole exponent is minus x. And now after this step, here we apply another exponential law. You know that if we have a to the power of m to the power of n, it is equals to a to the power of m times of n. So now we apply this exponential law on here, so these exponents are multiplied by each other, so we get here 1 is equals to minus x into e to the power of minus x into log of 27. We multiply these two exponents here, so we write it as e to the power of minus x into log of 27. Okay, so after this step, here you see that in order to apply this w function, the exponent of e is multiplied by here, so this is minus x log 27. So here we have only minus x, here we need log 27, so that now we multiply both of the sides by log of 27. So when you multiply log of 27, it will be written as minus x log of 27 into e to the power of minus x log of 27. So now in the right hand side, we are ready to apply the Lambert W function. So here we need to apply this w function on both of the sides, and it will be written as w into log of 27 is equals to w into minus x log 27 into e to the power of minus x log of 27. Okay, so now here we need to apply the definition of Lambert W function. So according to the definition of Lambert W function, the output of this type of function is equals to the exponent of e. So you see here the exponent of e is minus x into log of 27. Similarly, in the left hand side, we have only w of log 27. So now in here we need to make some work in the left hand side in order to find the value of x. So that here we first write this 27 as cube prime factors form, so that we need to we find the prime factors of 27, and these are 3 cubed. Okay, 3 cubed equals to 27, and this is equals to minus x into log of, here again you have 27, so we now again replace this 27 equals to 3 cubed. So now here we apply the property of log. So according to this property of log, we move this 3 in the front of this log, and it will be written as w of 3 into log 3 is equals to minus 3x. Here we again apply the property of log, and we move this 3 in the front of this log, and it will be written as minus 3x into log of 3. Okay, so here in the left hand side again we first write these term into the standard form of Lambert W function. So in order to standard form, we need to make here the exponential term with base e. So here we apply the log and anti-log on these 3 only. So okay, so here we first write this log 3, and now we apply the log and anti-log at the same time on these 3. So it will be written as e to the power of log 3 is equals to this is minus 3x into log of 3. Okay, so now you see here the exponent of e is log 3, and it is multiplied by here, so that now we are ready to apply the definition of Lambert W function. So according to the definition of Lambert W function, the output of this type of function is equals to log of 3. So it is equals to minus 3x into log of 3. And now you see here this log 3 is cancelled out by this. So now you see here this log 3 is cancelled out by this log 3, and we will get here 1 only, and in the right hand side we have minus 3x. So here we need to move minus 3 in the left hand side, so we get here x is equals to minus 1 over 3. So this is the final value of x in this problem. And now here we need to verify this value of x, so that in order to verify this value, here we need to copy down the given question statement. It is 27 to the power of x is equals to minus x. And now we substitute the value of x on both of the sides, so it will be written as 27 to the power of minus x is equals to minus 1 over 3 equals to minus times of minus 1 over 3. Okay, so now here we need some working on this, so that you see here we have we first write this 27 as 3 cubed, and its whole power minus 1 over 3 equals to, this is minus times of minus becomes plus 1 over 3. So you see here these 3 and 3 are cancelled by each other, so we get here 3 inverse is equals to 1 over 3. So that here we move this 3 inverse as 1 over 3 equals to 1 over 3. So this shows that the value of x satisfied our given question statement, and this is the final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.